Nice to meet you. I'm Khadr Chuktai and you're watching my YouTube channel School of Advanced Chemistry. Today I'm going to discuss the physical properties and the physical state, for example, melting, boiling, evaporation, freezing and condensation for O-level and IGCSE Chemistry students. Let's talk about it. What are the physical properties? Physical properties are the properties those are associated with physical phenomenon are called physical properties. Properties those are connected with the physical gesture, with the physical phenomena, with the physical aspects are said to be physical properties. For example, you will have to memorize some names. For example, melting point, boiling point, evaporation, freezing, density, volatility, electrical conductivity, brittleness, malleability. These are the few famous physical properties that you have to learn. Let's talk about the melting point. The first one physical property is the melting point. Point mean temperature. Melting is a stage of melting, and the melting point, the temperature at the stage of melting. The proper definition is a constant temperature at which solid changes into the liquid state. A constant temperature, a fixed temperature at which solids start to change into the liquid state. At that temperature, at that stage, the point is said to be melting point. For example, in this diagram, in this picture, you can see that ice is going to melt down. This ice is in solid state and it is going to melt down in form of liquid water. So the conversion of solid into the liquid state at a constant temperature is said to be the melting phase, and the temperature at this stage is said to be melting point. Basically, two phases exist at the stage of melting. One is solid, other one is the liquid. They both are basically, you can say, in equilibrium with each other. So two phases exist at the stage of the melting point. One is solid, other one is the liquid phase. The next one, temperature remains constant till all the solid is melted. Even a few crystal of the solid is present, then temperature will not change. Temperature is fixed. Temperature is fixed till all the solid is melted. So this is the conversion stage when solid changes into the liquid state and temperature remains constant. At melting point, the whole sample is having equal value of its temperature. When this ice cube is going to melt down, at the same time, the temperature of this ice cube will be equal to, let's suppose, 0 degrees Celsius, and this liquid that is being formed from this ice cube will also have the same temperature. So the whole sample, the whole mixture that is having solid and liquid, the whole mixture is having the equal magnitude of the melting point, melting temperature, and so on. The next one is test of purity. Test for purity or test of purity. And impure substances show lower melting point. So melting point is a tool to check the purity of a substance. If substance is impure, then its melting point will be lower and it will show the range of different sort of melting point. And its melting point will be lower as compared to its original component, its principal component. For example, in this case, we are going to melt down this ice cube. For example, this ice cube is having dust particle in it, or it's having some salt dissolved in it. So its expected melting point in case of this impure crystal, this impure ice crystal, this impure solid, this impure sample, its melting point will be lower down. Its melting point will be lower. It may be minus 5 degrees Celsius, it may be minus 10 degrees Celsius, it may be minus 14, 15 degrees Celsius and so on. So impurity decreases the melting point, lower down the melting point, but increases or elevate the boiling point of the substance. The second thing is an impure solid gradually melts over a range of temperature. Impure solid never shows sharp melting point. Impure solid never shows sharp value of melting point. So there is no sharp melting point if the substance is impure. Pure substances show sharp value of melting point. Impure substances, they show range of temperature, range of melting point. Some of the portion will melt down, let's suppose at 0 degree. Some of the portion is going to melt down at you can say -1 degree Celsius. Some of its portion may melt down at -5 degrees Celsius if this crystal is supposed to be an impure crystal. So basically impurity lowers the melting point, and the second one, impure solid gradually melt down over the different range of temperature. They are never going to show the sharp or the fixed value of the melting point. Now come towards the freezing point. That is the reverse of melting point. What is the freezing point? A constant temperature at which liquid changes into the solid state. When liquid change back into the solid state, this stage is said to be the freezing point. Once again, two phases exist like melting point, and they are solid and liquid. Both, one will be the solid, one will be the liquid. Temperature remains constant till all the liquid is solidified. Once again, the temperature will remain constant till there is the complete conversion of liquid into the solid state. Again, you can use this parameter for the testing of impurity or the purity of a substance. Test for purity. An impure substance has once again lower value of its freezing point, not the higher one, not the actual one. So it's not the actual one, it's going to be show the lower value of its freezing point. The next one is boiling point. Boiling point is a constant temperature at which liquid changes into the gaseous state. When liquid state changes itself into the gaseous state, but the temperature must be constant at that time. If the temperature is constant and liquid start to change into the gaseous state, at the time when the temperature is constant, number one. Number two, at that time when liquid start to change into the gaseous state or liquid is changing into the gaseous state, this stage is said to be boiling. This stage is said to be boiling, and you can say this temperature is said to be, the temperature at this stage is said to be boiling point. It's called boiling point. Once again, two phases exist. One is gas, one phase is the gas, another phase is the liquid phase. So two phases exist at the stage of boiling temperature or at the stage of boiling point. Temperature remains constant till all the liquid is boiled off. Temperature remains constant. Temperature will remain constant till all liquid is converted into the vapor state, is changed into the gaseous state, is boiled off. At the stage of boiling, the whole liquid have the same temperature. The whole liquid, you can check temperature at any level, at any portion of the liquid, and the whole liquid is supposed to have the same temperature during the course of that stage that is said to be the boiling. So stage of the boiling or the boiling point, whole liquid sample have same temperature. In case of pure liquid, vapors and the liquid both have same temperature. Once again, if it's a pure liquid, let's suppose it's a pure water, I am going to boil water, and these are the fumes of water, it's steam. So the temperature of the steam and temperature of water will be same, right? In case of pure liquid, liquid and its vapors both will be at the same level of temperature. In case of impure liquid, In case of impure liquid, for example, I am over here. In case of the mixture of salt and water, I'm going to heat, I'm supposed to heat the mixture of salt and water, or a sugar solution, you can say. Then this point will not exist. This point will not going to be valid in this case. Once again, in case of impure liquid like water solution, vapors are at low temperature, then the solution. Then this steam will be at low temperature. Its temperature will be 100 degrees Celsius, 100 degrees Celsius, and the temperature of this mixture may be 110 degrees Celsius. So the mixture, because it has become an impure mixture, so its temperature will be higher, and the temperature of the steam, the temperature of the vapor is lower. You can also use this tool, use this boiling temperature as a test of purity or impurity. So test of purity. An impure substance show higher boiling point. I mean, impurity elevate the boiling point. Impurity elevate the boiling point. As we have seen that impurity decreases the melting point, but impurity increases the boiling point. So that's why, let's suppose I'm boiling a solution that is an impure solution. Boiling temperature may be more than that of the principal component. The principal component is water. In this case, the principal component is water. Water boiling point is equal to 100 degrees Celsius. And now this mixture will boil off at more than that of the 100 degrees Celsius. So once again, impurity can be checked with the help of boiling point data. An impure substance show higher boiling point than that of its original or the principal component's boiling point. Why different compounds are having a higher boiling point and some compounds are having low boiling point? The value of melting and boiling point of any substance is dependent on the bonding and structure. The nature of bonding and nature of structure is going to govern the basic reason of high melting and high boiling point. Some substances are showing high melting point, some substances are showing low melting point. The reason is basically the type of bonding and the type of structure they are possessing. So that's why they are having different sort of melting and boiling point. Generally speaking, compounds having giant structure are having high value of melting and boiling point. In contrary to the giant structure, other one structure is a simple structure. Structure may be simple, structure may be joint. So simple structure molecule, the molecules, those are having simple structure, they will show low value of melting and boiling point usually, and the compounds are the macromolecule, those are having giant structure, they will have high value of melting and boiling points. So the pure substances will show sharp or the fixed value of its melting point, and its boiling point will also be the sharp and fixed. The next one is evaporation. Basically, the conversion of liquid into the gaseous state at any temperature is said to be evaporation. Conversion of liquid into the gaseous state, not the constant temperature, at any temperature, not at constant temperature. There is no condition for the temperature to be constant, not at constant. So it's said to be the evaporation. High kinetic energy molecule leave the surface of the liquid and they become vapor. They change themselves into the vapor. This phenomena happen repeatedly till all the liquid is converted into the gaseous state. So this conversion of a liquid into the gaseous state, into the vapor state is said to be evaporation. It can happen even at low temperature, right? It can happen at high temperature. It can happen at any temperature. This is the phenomena of evaporation. The next one is condensation. Conversion of gas into the liquid state. Conversion of gas back into the liquid state at low temperature, at lower temperature is said to be condensation. Is said to be the condensation. When high energy gaseous particle hit the walls or hit the surface, that is the colder one, when a high energy gaseous particle hit the cold surface, they lose their energy and condense themselves. They change their physical state from gas to the liquid state. So this sort of conversion, when gases are cooled, they change from gas into the liquid state. This conversion is said to be the condensation. This is called condensation. The important point, the main point that you have to remember is over here, substance having high boiling point. Substance having high boiling point condense more easily, more readily, more rapidly. Substance having high boiling point condensed, when they are allowed to condense, when they are allowed to cool down, they condensed more readily, more rapidly as compared to those are having low or the lower boiling point. So the compound of high boiling point are more readily condensed than that of the compound that is having lower boiling point. Water vapors condense more rapidly than that of the vapor of the ethanol. Water vapors condense more rapidly. The boiling point of water is equal to, a pure water is equal to 100 degrees Celsius, and the ethanol is having almost 75 degrees Celsius of boiling point, almost. Roughly 75 degrees Celsius. So what is having high melting point? So it will be condensed more rapidly, more easily as compared to the ethanol. The next one is sublimation. Sublimation is the transformation of substance directly from solid to the gaseous state. When a substance is heated, it changes its physical state from solid to the gas directly. When substance is heated, if it is changing its state from solid to the gaseous state, solid phase to the gaseous phase, without passing through the liquid stage, this stage is said to be the sublimation. For example, dry ice CO2 show the sublimation. When the solid CO2 is heated, it changes into the gaseous CO2. Right. Same is the case. This phenomena can be seen with from iodine, that is the solid iodine. Iodine also shows sublimation. It directly changes into the gaseous state when it is heated strongly. And the third one that you have to remember is ammonium chloride. Ammonium chloride is a solid that also shows sublimation upon heating. So sublimation is a transformation or transition stage, the conversion of a substance when it is heated from solid to the gas state. When a solid substance is heated, it changes its state from solid to the gaseous state without going into the liquid stage is said to be this phenomena, this procedure, this phenomena is said to be sublimation. The reverse of sublimation is also possible. We can change solid into gas, and upon cooling, this gas again can be changed into the solid state. Solid into gas and gas into solid just by lowering down the temperature. So this is sublimation. And this one is a reverse of sublimation. Now come towards a summary of the phase changes in a matter. You know there are basically three phases as far as our O-level chemistry syllabus is concerned. Matter may be in solid state, it may be in a liquid state, it may be in a gaseous state. The conversion of solid into the gaseous state is said to be the sublimation. Reverse is also true. When gas is cooled down and it is changing directly into the solid state, this is called reverse sublimation. The next one is when solid is heated, it changes into the liquid state, and once again the reversal, when liquid is cooled, when it is changing back into the solid state, it's called freezing. When liquid is heated and it is going into the gaseous state, it's called evaporation, or even if it is not heated, it's normally is being converted into the gaseous state, it's called evaporation. And when gas is condensed, when the gas is cooled down and it changes into the liquid state, this process is said to be the condensation. So overall, there are basically 6 processes: reverse sublimation, sublimation, freezing, melting, evaporation, and condensations. That's all about today. Thank you very much. Have a nice day.